For more information, please visit SGMAK Associates website.
Let's talk about discrete distributions. One of the major problems that students face is to identify the correct distribution when trying to solve a problem. So here we are giving you some feedback regarding Bernoulli trials. A number of distributions are based on Bernoulli trials. So how do you relate? How do you identify which distribution to use when solving a problem? So let's talk about a Bernoulli trial. Um, each trial has two outcomes only. We define one of them as success and the other as failure. And the probability of success remains constant in each trial. In binomial distribution, one of the commonly used discrete distribution, the random variable is defined as the number of success in a given in n Bernoulli trials. The number of trials are fixed. We're simply trying to find out how many successes we had in those trials. Geometric distribution, another distribution based on Bernoulli trial. The random variable of interest is defined as the number of trials required to achieve the first success. So you're making Bernoulli trials, you have defined the success, and in geometric distribution, you're focused on how many trials you need to get the first success. Pascal distribution, also known as negative binomial distribution. The random variable of interest here is, we define it as the trial on which rth success happens. So random variable takes a value equal n if rth success occurs or happens on nth trial. So number of trials needed is a random variable here, but we pre-specify the number of success we need, and we try to find out on which trial the last success, the rth success, happens. Another related distribution based on Bernoulli trial is hypergeometric distribution, which is very closely related to binomial distribution. And we'll talk about the approximation of hypergeometric to binomial later. We define the random variable as the number of items belonging to a category in a finite population of n items with d items belonging to the category of interest. So a common example would be you have a box full of objects, and a box has a known number of objects, let's say 100, and you know that there are 10 defective objects in that. Now you draw a random sample and you try to find out how many defectives are in the sample. You can use hypergeometric distribution here. Once again, Bernoulli trial is the foundation for binomial, geometric, Pascal, and hypergeometric. So let's look at an example, which will, depending on what's the objective or the basic question, it will take you from one distribution to another. So the example, the problem statement is as follows. An inspector is walking along a long pipeline. It has welded joint every 100 feet. So the inspector goes to a joint and checks for weld integrity. And the welding process used was such that it generated 1% defective. So on average, 1 out of every 100 joint is defective. Weld is not good. The inspector continues to work until he finds 3 defective welds. So we are interested in the following events. We want to find the probability of the event that the inspector walks 5,000 feet, the probability of the event that the inspector has to walk more than 5,000 feet. So first, inspecting each weld is to be treated as a Bernoulli trial, because when you are inspecting a weld, outcome could be that the weld is defective or non-defective. And if you define success as finding a defective weld, then we have a probability of success in each trial as 1% or 0.01. Then the first part of the problem calls for use of Pascal distribution because you want to estimate the probability of finding the third defective weld on the 50th trial. The person has to walk 5,000 feet. So on the 5,000 feet, that means on the 50th joint, if it happens to be the third defective, he stops there. The second part of the problem asking for what is the probability we get less than 3 defective in 50 Bernoulli trial, because the rule is that person continues to walk until the person finds 3 defective welds. What's the probability that person will walk more than 5,000 feet? So it translates to what's the probability the number of defects is less than 3 in 50 Bernoulli trials, and this is an example of binomial distribution. So first part of the problem can be solved using the Excel function for negative binomial distribution, and we will use the negative binomial distribution here, and Excel reads as negative binom distribution. It requires 4 input. For this problem, we'll use 47, 3, 0.01, false, and the number is 0.007. The first input indicates how many failures occurred prior to the third success. And in our case, that should be 47 because third success is happening on the 50th trial. Now, third success happens to be the second input also. Probability of success in each trial is 0.01, same as finding a weld to be defective. And the last input is false because you want to estimate that specific probability, not the cumulative. So 0.007 is the probability of finding third defective weld on the 50th trial. Now, second part of the problem can be solved using a binomial distribution. The probability of the event of interest is given by binomial Excel function, binom dist. We're trying to find out less than 3 defectives, so 0, 1, or 2. So if first input is 2, we had 50 trials. Probability of success in each trial is 0.01. And since you're interested in cumulative probability, we put the fourth field or input as true, and the number is 0.986. So this is 0.986 or 98.6% chance that we'll find 2 or less defective welds in 50 trials, or there's a probability of 0.986 that the inspector has to walk more than 5,000 feet. Now, let's look at another variation of the same problem. If you're interested to estimate the probability of the event of finding the first defective joint on the 10th trial, that means you have walked 500 feet, you're on the 10th joint to be inspected, and that's the first time you find in that trial you find the defective joint. So previous 9 joints are all good, and the first defective joint happens to be on 10th trial. What's the probability of this event? So this is, we're trying to find out the probability of finding or if probability of interest that we want to find the first defective joint on the 10th trial. So you're fixing which trial number, which happens to be 10th, and that 10th trial happens to be the first time we find a defective joint. And that probability using binomial distribution come out to be 0.009. So the key thing here is, for this part of the presentation, is to show you that as you read the problem statement, you need to identify that you're dealing with the Bernoulli trials, and depending on what you're trying to answer, it can take you to different distribution. So you need to be clear about the signature from the problem that will take to a specific distribution. Hopefully this is of help to you.
For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website.